Welcome to the engineering projects of building a wind turbine from a washing machine motor. Begin by disassembling the original direct drive motor assembly with extreme care. The rotor shell, housing the permanent magnet system, is lifted out of the copper stator. To use a high-speed electric drill to remove the bolts, securing the stator coil. The original magnetic circuit needs to be modified to optimize the output voltage characteristics. He uses pliers to decisively cut and completely remove the original phase wire connections. 4 new electrical cables are securely soldered to change the configuration of the energy harvesting coils. The modified stator assembly is fitted perfectly back onto the central aluminum bracket. Tighten the positioning bolts using a drill to ensure the standard air gap. The output ends are carefully stripped and insulated to set up the load testing system. A standard 220 volts AC LED bulb is wired directly to the generator circuit. By simply giving the rotor a light spin, the cutting of magnetic flux continuously lights up the AC bulb. Proceed to perform an in-depth verification using a Victor VC 830 multimeter on the AC scale. Spinning it by hand shows that the generated AC voltage immediately jumps to around the 130 volts threshold. To harness energy efficiently, the device needs an aluminum bridge rectifier added. The 2 AC output wires are clamped and securely soldered to the rectifier input. Observing the multimeter on the DC scale, the post-rectification DC voltage peaks at 186 volts. The system is then loaded with a 12 volts DC LED bulb to evaluate its stability. A stand fan is turned on, blowing a stream of air directly at the possible rotor magnets. Simulating wind power shows that the 12 volts bulb maintains brilliant brightness with absolutely no flickering. The generator unit is then positioned onto a sturdy square steel frame. Using an electric drill to tightly drive screws through the plate, the turbine structure is absolutely secured. He uses a marker to precisely trace a 5-pointed star on a flat zinc plate. An angle grinder cuts sharply to remove the excess, creating a pentagonal center disc. Using a tape measure and a marker to accurately measure the lengths of the rectangular aluminum tubes. Each mark is drawn meticulously to ensure static concentricity for the entire blade system. A high-friction cutting disc neatly cuts off 5 primary load-bearing aluminum frame bars. Using arc welding tongs to spot weld and firmly attach the aluminum arms to the pentagonal center disc. The melted arc welds connect the aluminum brackets to the steel plate extremely evenly. The structure of the basic 5-point star frame is now complete with high geometric symmetry. The technician adds a central vertical shaft to act as a pivot for driving the blade system. The skeleton is further reinforced with horizontal crossbars to disperse the centrifugal forces during rotation. Continuous spot welding helps eliminate thermal warping on thin materials. Use a mechanical tri-square to check parallelism and ensure aerodynamic efficiency. The overall cage of the vertical axis turbine has taken shape, optimally designed for multi-directional winds. Next is fabricating the wind-catching blades. He uses masking tape to mark the PVC pipe. The angle grinder precisely cuts the pipe's body. This weather-resistant plastic is ideal. The PVC pipe section is heated on an electric stove, utilizing its thermoplastic properties for shaping. After being slit lengthwise, the plastic sheet is pressed flat by the weight of a solid granite slab. The resulting products are perfectly flat, lightweight PVC panels with high mechanical durability. Small leaf hinges are used to create a flexible folding blade mechanism. The screwing points on the crossbars are meticulously marked with a fine-tip correction pen. The hinges are securely fastened with self-drilling screws, setting up the vertical axis rotating blade system. The wind-catching PVC panel is test-fitted. A steel drill bit creates the holes, precisely guiding them on the plastic surface. Use a rivet gun to press the plastic sheet tightly against the hinge, preventing loosening caused by vibrations. The smart blade design features a stopper pin, welded in place to limit the maximum wind-catching opening angle. Repeat this process for the entire blade assembly. The opening and closing structure helps reduce drag on the reverse cycle. The rotor system of the vertical wind turbine is test spun, demonstrating excellent dynamic balance. The galvanized frame is coated with pink spray paint to protect the surface from environmental corrosion. Moving on to the single-axis transmission mechanism, a high-strength threaded steel is brought out for deep machining. A drill press mills through the solid steel, creating a positioning pinhole to prevent rotational slip. The galvanized steel pipe is then drilled with a shaft hole. It will act as the torque transmission sleeve. The deep groove ball bearing is tightly pressed into the steel casing using a hammer, ready to withstand radial loads. The bearing assembly is clamped into the vise to begin the assembly process of the central rotating shaft. The threaded shaft is inserted into the steel pipe, and a metal clamping pin goes through the coaxial hole to lock the movement completely. A basic mechanical coupling is formed, ensuring the torque is transmitted intact along the axis. Use a marker to draw dividing lines. Then use an angle grinder to cut slots at the end of the steel pipe to create an elastic clamping structure. Drive the bearing casing assembly into the newly slotted pipe end. The tight assembly tolerance requires strong hammer strikes. Arc welding is used to permanently lock the cut slots, integrating the bearing assembly into the main transmission pipe. To remove the welding slag with a hammer and a wire brush, to ensure the uniformity of the metal joint. The other end of the pipe is fitted with a second bearing assembly, completing the double-ended support system. Brought to the drill press, a through hole is machined for driving in a locking pin to eliminate the risk of longitudinal sliding. Utilizing the bevel gear reducer from a broken angle grinder, assemble and tighten the nuts to synchronize the shaft. The outer steel pipe is fitted into the grinder's support base, and a positioning pin is driven through to secure the mechanism. An octagonal blanking plate is centered on the gear shaft, then permanently welded onto the disc shaft. Moving on to processing the old motorcycle tire. A wide blade cuts the rubber casing to create a strip of friction-resistant material. The rubber piece is cut into 4 equal segments. This design acts as a flexible coupling to absorb shocks. Cut the rubber horizontally, drill, and screw it onto the disc. to form a flexible friction drive mechanism. The assembly process moves up to the roof, where welded square steel tubes create a solid foundation base. The transmission shaft assembly is brought onto the integrated support, with the frame placed next to the solar panels. The rubber spoke mechanism is pressed into the generator's sprocket, creating a smooth and grippy friction drive system. The vertical axis wind turbine is lifted and inserted into the rotating shaft. The PVC wind blades are ready to catch the airflow. The fully completed vertical axis wind turbine system has been positioned on the roof and begins to spin on its own. The rubber friction drive firmly grips the sprocket, perfectly eliminating dynamic vibrations. A large fan is turned on to simulate a wind stream, and the rectified voltage stabilizes at 47 volts DC. To verify the load current, a strip of super bright LED modules is connected directly into the circuit. Alligator clips supply power, illuminating the LED block, improving the extremely efficient power generation capacity. The turbine blades automatically open and close to capture wind kinetic energy, maintaining a stable rotation speed for the system. The right-angle transmission from the reducer operates smoothly, delivering powerful torque. An amazing project turning an old washing machine motor into a sustainable green renewable energy station.